Hello everyone, so at this point let me just discuss to you the power supply. But before discussing the power supply, let me give you a quick idea of the importance of our power supply. The first block diagram that you are simply seeing is the application of your power supply. All electronic circuit will require a steady voltage, that is DC, and voltages are actually in low voltages, such as 5 volts, 9 volts, 12 volts. If that is the case, then we will not use a direct 220 volts that is alternating. There must be a supply of power that can produce the required steady voltage, and that is the power supply. So all electronic circuit would require a power supply to have a steady voltage. Example of this is our personal computer. So our computer unit has an internal power supply to provide steady voltages for the circuits. We also have our cell phones. Our cell phones is operated by a battery. If the battery of the cell phone gets in a low level, then we apply a charger to charge the battery. So the charger is like the power supply, where the main source of voltage is from the outlet or from the AC, and then it is plugged from the AC, and the charger itself has its own power supply to sustain or to provide the required voltage for your laptop or for your cell phone. Right? So that is how important is your power supply. There is a need for a power supply since your electronic gadgets or electronic circuit or your electronic load will only need a low voltage that is steady. The second block diagram that you are seeing is the functional block diagram of a power supply. So we have the source of AC, followed by a transformer, followed by a rectifier, followed by a filter, and followed by a regulator. AC is an alternating current, and the outlet that we have provides a 220 volts that is actually alternating. Now, since the voltage here is 220 volts, then it must be applied to a transformer. Remember that we are to apply a power supply which is a low voltage. So if that will be the case, okay, the next block diagram is the transformer. So the application of if this is your power supply, the whole power supply block diagram is this one. So you start with the AC with a high voltage. High voltage is not needed, so you have to use a transformer. So what type of transformer that are you going to use? The step-down transformer. As you recall, we have what is known as the step-up transformer, and we also have a step-down transformer. Alright? So for the step-up transformer, from 220 volts, it will increase the voltages. For a step-down transformer, the 220 volts now can be stepped down as low as 12 volts, as low as 9 volts. So in the case of power supply, what we are going to use is the step-down transformer. So meaning to say, from 220 volts, we can actually use, for sample purposes, we can apply a step down of 9 volts or 12 volts. So your supply or the waveform now will simply look like this. So as you can see, there is now a decrease in amplitude. So when we say amplitude, that is the height, the maximum height of your signal or your source voltage. Next, since the target is to have a DC or a steady voltage, since the target is to have a DC or steady voltage, then we must remove part of the alternating voltages. We can retain the positive values so that we can have a DC voltages, or retain the negative values so we can have a DC negative voltages. So in order to do that, we have now to pass this signal or this voltage to a rectifier. So a rectifier, we have different types of rectifier. The first one, we have the half-wave rectifier. The second one, we have a full-wave rectifier. For a full-wave rectifier, B.1, we have what is known as the center tap rectifier. B.2, we have what is known as the bridge type rectifier. Okay? So the rectifier, the main component for the rectifier is the diode. That's the reason why we have what is known as the diode rectifier. It will rectify now the input signal and will produce this output. So it will produce this output now. Right? So instead of having a positive and negative or an alternating values, upon this signal passes through the rectifier now will simply remove all the negative values, leaving only the positive. That way, we could also have another way around. Instead of removing the negative values, we can remove all the positive values, okay, and retain all the negative values. So in this case, all values are negative, so there is now a direct current. There is no more change of polarity of voltages, but instead we are now steady in a negative value of voltage. Next, so say for instance we will consider the rectifying only the negative value. Now this rectified signal, which is now considered to be a pulsating DC, once a signal, a voltage, an AC voltage passes a rectifier, it is now considered to be a pulsating DC. Let me repeat again. It is now considered to be a pulsating DC. Why pulsating? So this is now considered to be, this signal now is considered to be a pulsating DC. Why pulsating DC? As you can see, there is a value that is low and there is a value that is high, another value that is low, another value that is high, which is pulsating. It is not yet a direct current, but the values are all positive, therefore this is already a direct current. Why? Because all values are positive, there are no alternative values. Now, to improve this signal, the signal must pass to another circuit, and that is what is known as the filter circuit. So the filter circuit now will improve this pulsating DC and will produce this output. So from a pulsating DC, after applying the filter, the output of the voltage will be smoothened by this circuit. Now for this circuit, the responsible component to smoothen or almost flatten the signal is the capacitor. But then again, this is not the target voltage. The target voltage is a direct flat voltage. So meaning to say this signal must pass through a regulator. Once this signal passes through the regulator, the output will be like this. Okay? So after this signal passes to a filter, the filter with a capacitor smoothens the signal. But then again, this is not the target voltage, but rather a flat voltage. So it has to pass another circuit, and that is a regulator. The responsible component in regulating the voltage to a smooth, flat shape or signal is the regulator circuit. So the main component for a regulator circuit is the Zener diode. So this is now our target. So this is now the DC voltage, which has a constant voltage or a stable voltage. So this is now the required output for a power supply. So you can now use this one to your electronic circuit or load. It's because after achieving this whole block diagram, you can now, at the end of the regulator, you can now apply your power supply to any electronic load or electronic circuit. Why? Because from an AC source, your signal now is a direct current. Take note, for the rectifier, the output is already DC. The output of the rectifier is already DC, only pulsating. Only pulsating. This is already a DC class. This is already a DC. So this is the output of a rectifier. It is already a pulsating DC, but not the desired. The desired DC is a flat one. So it has to pass through a filter to smoothen it, and it has to pass in a regulator to regulate the voltages to a stable value.